Clapeyron. Emile Clapeyron is credited with having formulated the ideal gas law in 1834. Take a minute to look at the algebra that describes the relationship between pressure, volume, temperature, and the quantity of gas in a system. This simple statement represents the culmination of the work of dozens of scientists over hundreds of years, and it includes the discoveries of the scientists recognized in this lesson.
P equals pressures in atmosphere, V equals volume in liters, N equals moles, R equals ideal gas content equals 0.0821 liters atmosphere or mole Kelvin. T equals temperature in degrees Kelvin.
The combined gas law is great. We can manipulate pressure, volume, and temperature. What about moles of the substance we're using? Before we add moles to our equation, we need to figure out what its relationship is with the other variable and find out if the identity of gas matters. Because of Avogadro's hypothesis, equal volumes of gases at the same temperature and pressure have the same number of particles. This means the identity of the gas will not matter, just the number of moles. As you increase the number of atoms in a balloon, by blowing air into the balloon, the volume increases. The pressure is the same because the balloon can expand. The temperature is the same, so moles and volume have a direct relationship. Since volume and moles are directly related just like volume and temperature, we can put the number of moles, or N, next to temperature. But now we are holding nothing constant, so let's hold one entire side constant by setting it to the STP values and call it K, and we can get rid of the division by multiplying on both sides. You don't need the subscripts anymore either, and you get PV and RT, the ideal gas law. So much beauty in such a small mathematical equation. Let's talk about what R is exactly.
Remember, the R values is created from the equation set to STP values. So we plug in the value of pressure, the volume of a mole at STP and temperature. But remember all those pressure values. They are different R values for different pressure values. So make sure you check your problem to see which units to use. At what pressure would 0.150 mole of nitrogen gas at 20 degrees occupy 8.90 L? Use PV and RT and get pressure alone by dividing both sides by volume.
Now, the ideal gas law makes some assumptions about ideal gases. So let's compare ideal gases and real gases. Ideal gases have no volume, but of course that isn't it the reality. Real gases have volume. Ideal gases have no molecular attractions, but real gases are attracted to each other. When they cool down, they stop being gases and will form liquids and solids. Ideal gases follow the gas laws at all pressures and temperatures, and real gases will differ at low temperatures and high pressures. So basically, there is no such thing as an ideal gases, but the real gases behave like ideal gases in many conditions. This is why we can still use PV equals nRT.
556 moles of gas occupy at a pressure of 715 millimeters mercury and a temperature of 58 degrees Celsius. Let's identify our given and what we are finding. Our given is moles, pressure, and temperature, and we're finding volume. Step 1. Convert to proper units. Using our temperature in Celsius, we want to convert 58 degrees Celsius to Kelvin. We'll add 273 to get 331 Kelvin. Now let's change our pressure into atmospheres. Remember, 1 atmosphere equals 760 millimeters mercury. That is our conversion factor that will allow us to get from millimeters mercury to atmospheres. We'll align the millimeters mercury so they can cancel, and we'll be left with just atmosphere. After we divide these two values, we get our new pressure in the proper units.
Step 2. Plug it into your formula of PV is equal to nRT. We'll plug in our pressure in the proper units of atmospheres. Then, we'll multiply that pressure by our V or our volume. Set this equation to our N or our moles. Then, multiply our gas. And lastly, we'll plug in our temperature, which is in Kelvin. Multiply each one of these values. Now that we've multiplied it, we will divide 0.9407 to 15.1019 to get V by itself. After we divide these two values together, we'll get 16.05. But we want to round 3 sig figs, and our final answer will be 16.1 liters.